Okay, let's start with question number one. So the next few questions are going to be about normal distribution. What we need to know about normal distribution is it always takes the data, and when you plot the data, it falls into this beautiful bell curve, right? And so I've got on your formula sheet what that bell curve looks like, as well as the percentages that fall in between what we call standard deviation. So let's start with making sure that we understand what these variables mean. Z is going to be for your z-score. That's sort of like a standard deviation, but it's for a specific data point. So it tells you how far away from the mean your data point is. X is the specific data point. Mu is your mean. And this little symbol sigma is your standard deviation. And we learned in the last section with statistics that these are the symbols that we use for a population. So we've got all of the data information in order to create this normal curve or normal distribution. Okay, so knowing that, let's start with question number one. Let's circle all of the true statements. Normal distributions are symmetric. So symmetric means that you could fold it in half and each side would be equivalent. You can definitely do that with a bell curve, splitting it right there at the mean, and each side would be mirrored. So yes, normal distributions are definitely symmetric. The mean is always larger than the median. So if you read your textbook, if all of your information is distributed evenly, then the middle is also the average. So your mean, median, mode should all be the same thing. So your median is also centered. One is not larger than the other, so you don't want to click that. That is false. Approximately 68% of the data lies within one standard deviation. So if you learned the empirical rule, you know that 68% falls between plus or minus one standard deviation, 95% falls within two standard deviations from the mean, and then 99.7% falls within three standard deviations, which I've got broken down into each section in the picture that you're going to be given. So when we ask, is 68% within one standard deviation? Yes, that is true. You can also see it visually here. The tails touch the horizontal axis. So while my picture shows that the tails are touching, or looks like they're touching the x-axis, part of the definition of a normal bell curve is it does go on forever, getting infinitely close at the ends to the x-axis, but it never touches. So we could always say that there's a chance, a very, very, very small chance, far out on the extremes of the curve, but we never say that's impossible. So this would also be false. It will not touch the horizontal axis. And then 50% of observations are above the mean. That is true. 50% are going to be above, 50% are going to be below. Okay, question number two. A snack company reports that its mini cookie packs contain a mean of 40 cookies with a standard deviation of 3 cookies. Draw a bell-shaped curve of the normal distribution. Rather than starting with my curve, I generally will start with my horizontal axis, and instead of labeling them with all of the symbols, I'm going to label them with the numbers for this particular situation. I'm going to always center it at the mean, which is going to be 40. And then the mean plus 1 standard deviation would be 40 plus the 3, or 43, 46, and then 49. We only generally draw out 3 standard deviations, and then subtract 3 on the left. So we've got 37, 34, and 31. And then I'll draw my curve. Again, you probably shouldn't touch the x-axis, but you're going to just hover over it and then peak it at 40 and then draw it to the right. Doesn't have to be perfect as long as I knew that you were trying to be symmetrical. Okay, so there's your bell-shaped curve. And then what percentage of packs will have between 37 and 43 cookies? So what we want to do is find where 37 is, find where 43 is, and then try to figure out based on either the formula sheet distribution that you're given or using what you know about the empirical rule to be able to determine what percent fall between those two numbers. So you can see there that 40 is centered and 37 is one standard deviation to the left. 43 is one standard deviation to the right, so that would be 68%. Or you can find that by adding 34% plus 34%. If you didn't have the empirical rule memorized, you can use the distributions between. And what percentage will have fewer than 37 cookies? So when we looked at this one, we're asking 37 and fewer, since 37 is mu minus 1 standard deviation. If I put 37 on that bell chart, you can now see I want to add up all of the percentages less than that, starting at the 0.15%, added 2.35%, and 13.5%. Or I do want to mention the other way that you could approach this problem is I could instead take 100%, which is all data points, and subtract off anything greater than. And now there's a lot more percentages broken up in the greater than if you added them individually, but you could say anything from the mean or median on is 50%, and then anything from -1 standard deviation to the right is 34%. So everything to the right of 37 is 84%. So that means everything to the left is 100 minus 84%. We call that the complement, which is also 16%. So a couple ways that you can find that percentage. You choose which makes more sense to you. Okay, question 3. Suppose SAT scores are normally distributed with a mean of 1,050 and a standard deviation of 100. What percent of students scored above 1250? So what we want to do is figure out 1250 in relationship to the mean, and 1250 happens to be the mean, which is 1050 plus 2 standard deviations. Okay, so our 1250 is the mean plus 2 standard deviations. So it's sitting 2 jumps to the right of our mean. So what percent of students scored above 1250? So I am looking for every data point to the right of that. So we can just add up those two sections from 2 to 3 and then 3 to infinity. That would end up being our 2.35% plus 0.15% equals 2.5%. So only 2.5% of the data falls above this student score of 1250. So they did better than 97.5% of students, or 2.5% did better than that. What percent scored between 950 and 1250? So again, we're dealing with the 1250, but now we need to know 950 in relationship to the mean. 950 happens to be 10 minus 100. So that's the mean minus 1 standard deviation. So it's sitting 1 hop to the left of the mean, and you want to know everything in between. So if we're looking in between those two, we would add up 34% twice, which is basically that 68% between the 1 standard deviations plus 13.5%. If you need to, grab your calculator, but that ends up being 91.5. So that's a good chunk of students. Most students end up, 91.5% of students will end up between those two scores. Okay, question number 4. Let's match each scenario with the correct z-score interpretation. So as I mentioned with the z-score formula, z-score basically is for a specific data point, how far away is it from the mean in terms of like standard deviation? So z-scores can end up with decimals behind them instead of just integers. So we can have a negative 1.25 or a negative 2.58 away from the mean. So if your test score was better than the class average, then you should fall to the right. And that would mean that your z-score should be positive. If you earned exactly the average, then that means that we don't add or subtract from the mean. So your z-score is 0. And if you ran a slower time than your friends in a race, then you would fall to the left or your z-score should be negative. So that's just helping test on whether you understand where you end up location-wise. Okay, question number 5. Heights of adult cats are normally distributed with a mean of 9 inches and a standard deviation of 0.6 inches. So a cat has a score of 1.5. What's its height? So we're going to use this z-score formula and we're just going to plug in what we know and solve for the unknown variable. Since we do know the z-score, that's going to be the data point that's going to be on the left. X, remember, stands for your data point. In this case, that's the height, and that's my unknown. So it's X minus mu, or 9, and then divide by 0.06. Now we just solve this algebra. Make sure that you multiply both sides by 0.06 to get rid of the fraction first. Taking my 1.5, multiplying it by 0.6, we get 0.9. That's going to be equal to x minus 9. And then I'm going to add my 9. Okay, so this cat would have a height of 9.9. Make sure you don't just box x equals 9.9 because we want to interpret it in the real world. They ask you what's the height of the cat. You wouldn't say x equals 9.9. You would say the height of the cat is 9.9 and then add the unit inches. And then we're going to do similarly with the cat that has a z-score of negative 2.2. Because it's negative, I know my answer means that it's going to be less than 9 inches. But let's go ahead and do the math. So putting negative 2.2 in for z, we still have that same numbers on the right, x minus 9 over 0.6. Let's multiply both sides by that 0.6. So taking my calculator here, I'm going to take 0.2, making sure that's negative, multiplying it by 0.6, and that gives me a negative 1.32. And then I'm going to add over that 9, and we end up with x is equal to 7.68 inches. Again, noticing that that is less than the average of 9 because it was a negative z-score. Okay, jumping to number 6. Headphone battery life in hours is distributed normally with an average of 15 hours and a standard deviation of 2. What's the z-score if your phone has a battery life of 10 hours? So, you can only charge it for 10 hours. Is the phone company going to replace these headphone company replacing your headphones? Okay, if it's unusually low. Okay, so unusually, we're going to use the definition mentioned in the book. And by unusually low, what they say is if it is past a standard deviation of the mean plus or minus 2 standard deviations. So if it was a negative 2.2 standard deviations, we call that unusually low. or if it was a 2.2, we would say that's unusually high. Okay, so what we want to do is find the z-score. This time we don't know z, and we're going to fill in, remember it's the x, the data point, which in this case is my headphones are only charging for 10 hours or lasting for 10 hours, minus 15. Notice that's going to give me a negative number, and divide it by 2. So we get negative 5 divided by 2 is equal to negative 2.5. So is that beyond 2 standard deviations from the mean? We would say yes, the warranty should cover replacement. Okay, question number 7. The distribution of weights for newborn babies is approximately normally distributed, we probably don't need both those words, but is normally distributed with a mean of 7.3 pounds and a standard deviation of 0.8. Find the range of weights that contain approximately 68%, 95%, 99.7% of the data. So that's our empirical rule. So I want to find plus or minus 1, 2, and 3 standard deviations from the mean. So what I would personally do here is instead of drawing the bar or bell curve, I'm going to just find the numbers along the bottom. So I'm going to find or start with the mean, which is 7.3. And then I'm going to go 1, 2, 3 standard deviations above and 1, 2, 3 standard deviations below. And all I need to do is add or subtract the 0.8 pounds to get the rest of those numbers. So I'm going to start with my 7.3 and add 0.8. So I've got 8.1, right, for the next one. Add the next 0.8, so we get 8.9. And then add the next 0.8. So that would be 9.7. And then we would, again, on the other end, take 7.3 minus 0.8. That's 6.5 minus 0.8, and then minus 0.8. We can see those numbers there. We've got 6.5 is 1 standard deviation to the left, and then 5.7 is 2, and then 4.9. And then you'll use those numbers to fill in the rest of these. So 68% of the data falls within positive and negative 1 standard deviation. In this case, that would be my 6.5 to 8.1. 2 standard deviations is going to be my 5.7 to 8.9. And then 3 standard deviations is going to be babies weighing between 4.9 pounds and 9.7 pounds. Okay. Again, just to reemphasize that unusual, anything beyond that 95%, so anything less than 5.7 would be considered unusual, or anything greater than 8.9 pounds would also be considered an unusually heavy baby versus an unusually light baby. Okay, question 8. Based on the graph of the normal distribution prices below, answer the following questions. So now they've given you a bell curve and you're going to interpret it. So I'm going to know that 2000 is the mean. 2055 is the mean plus 1 standard deviation. This is going to be plus 2 standard deviations, and then 3 standard deviations from the mean. So if I asked, what is the approximate percentage of prices less than 2,110? You're going to find where that's at, right? And then determine, am I looking above or below that? Because I said less than, I'm going to look below it. Okay, and if I look at my percentages given to me, I'm just going to look down here in this bottom corner. I could add up all of those percentages less than 2 standard deviations to the right, or because there's less numbers here, my preference is to take the numbers greater than. So I'm going to take 100% and subtract off the numbers greater than, which is 2.35% plus 0.15%. So I get 100% minus 2.5%, which is 97.5%. Okay, so most of the prices, 97.5% of the prices are going to be less than we should probably have if we're talking about prices, dollar signs there. But question or part B, what is the approximate percentage of prices between 1890 and 2055? So we're just going to take those and shift them over to our breakdown on our distribution of percentages. And 1890 is two normal distributions to the left, and 2055 is one to the right. And so what I'm going to want to do is add up those percentages. In this case, it's 13.5% to get between -2 and -1, and then 68%, or you can add up 34 plus 34. And that ends up being 81.5% of data falls between those two price values. Okay, one more normal distribution problem, and then we'll jump to the trig. The heights of men are normally distributed with a mean of 69.8 inches and a standard deviation of 2.69. And the heights of women are also normally distributed, but have a mean of 64.6 inches and a standard deviation of 2.5 inches. Okay, so you've got a man who's 76 inches tall, and you want to know what's his z-score. So again, just use your z-score formula. Z is going to be equal to this person's data point, 76 inches. You're going to subtract the mean for men, comparing him to men, not the women, and then divide by the standard deviation for men. And for this woman who's 71 inches, we're going to do the same thing, except for we're going to use 71 for her data point, 64.6 for comparison to other women, and then divide by 2.51. So we are going to take, let's take 76 minus 69.8. Hit enter if you're going to do this one step at a time. 76 minus 69.8. Hit enter if you're doing this one step at a time. Then divide that answer by 2.69. And I get an answer of approximately, and z-scores are always rounded to the nearest hundredth, just traditionally. So we're going to put 2.30 for the man's z-score. Now calculating the woman's z-score, 71 minus 64.6 equals, and then divided by 2.51, or you could have used parentheses around the numerator. And the woman's z-score is approximately 2.55. Now comparing those, 2.55, if we thought about that on a number line, that is to the right of 2.3, so it becomes more unusual. Or when it asks for taller, we want to look for the larger or the furthest away in the case of like a negative z-score. So even though the man is taller, the woman is taller in relationship to other women. Let's jump to question number 10 here. Now we're getting into trig. A phone line runs east along a field for 2 miles and then north along the edge of the field. So we're going to go east and then you're going to go north. So you've got this field up here for 2 miles east, 2.5 miles north. And if the phone line costs $2,500 per mile to install, how much could have been saved if the phone line had been installed diagonally across the field, round to the nearest dollar? So the way I like to do this problem is I'll actually find the cost of going around the field, and then I'll find the cost doing it through the field, and then I'll subtract. So if I went around the field, I'm going to end up going 4.5 miles to install this phone line, and then I would end up multiplying that by 2,500. So let's do that. Okay, let's take our 2.5, add our 2, Find that answer first and then multiply it by $2,500. And we end up with a cost of $11,250. So if I went around the field, that's how much it costs. Versus if I go diagonally, I need to know the distance if I cut across. Because this is a right triangle and I only am dealing with sides. If we throw in angles, that's where you're going to want your trig functions. But if I'm only dealing with sides, we're usually just dealing with the Pythagorean theorem. You need to have memorized that the Pythagorean theorem is a squared plus b squared equals c squared, where c is your hypotenuse, and then a and b are your legs. And legs are what connect your 90-degree angle. So it doesn't matter which one you call A and which one you call B. So I'm going to start by saying the sum of the two legs squared is equal to my diagonal. In this case, I called it x squared. And now we have a little equation to solve. This is 4 plus 2.5 squared is 6.25 equals x squared. Now we have 10.25 equals x squared. And then we're going to take the square root of both sides, undoing that power of 2. And the primary root of 10.25 equals 3.201 or 3.202 if I keep it 3 places. I'm going to just keep that in my calculator. That's my miles. Notice I saved more than a mile because it was 4.5. So I should be saving more than 2,500 off of this. I'm going to multiply that by 2,500. So that's per mile. If you remember that in our dimensional analysis, miles are going to cancel, leaving me just dollars. So keeping this in my calculator, multiplying it by 2,500, I get the diagonal cost is going to be $8,003.91 if I round to the nearest cent. Okay. And then to find how much I saved, I'm going to want to subtract those two. So I like to just hit minus the 11,250 and then know that answer will be positive instead of negative. So we know a savings of $3,246.09 by cutting across the field. Okay, question 11. TV screens are measured on the diagonal. If we have a TV cabinet, so we have a cabinet that is 64 inches long horizontally and 52 inches high. So I'm assuming I've got kind of this rectangular space that I'm trying to fit my TV in. So I have 52 inches and 64 inches horizontally, and I want to know how large I can fit a TV in that space. Now, I will tell you, realistically, it's a little more complicated than this because TVs come in like a 16:9 ratio. So we're just going to do this as if this ratio is actually fine, and we're trying to figure out the diagonal because that's how TVs are measured. So you have 3 sides, you have a triangle, you don't have any angles here that you're dealing with. So all we want to do is use our Pythagorean theorem. We know that a squared plus b squared equals c squared. And the 2 sides meeting the 90-degree angle are 64 and 52. And we're just going to do similarly to what we did before. 64 squared plus 52 squared. That ends up being 6,800. That's equal to c squared. And then we're going to take the square root of each side. So let's take the square root of my answer. And I get c, or x, is approximately 82.462 inches. Now, in the real world, you can't buy a TV that says it's 82.4 or whatever. So I'm going to round that down. Even if this was 82.9, that means that an 83-inch TV is going to probably not fit. Always round down in order to fit it. I'm going to go by a max 82-inch TB. Again, though, ratios here are actually not quite correct with the TB. So, okay, question number 12. A playground slide is 14.5 feet long with an 8.5 tall ladder, so vertical. What is the measure of the angle the slide makes with the ground? So we're looking at the ground. I'm going to go ahead and draw my ground here. And what angle or where I draw the angle is super important. So be careful there. If I said the angle that the slide makes with the ground, make sure you're drawing the angle that we're talking about with the ground. Because when we talk about labeling our words for our trig ratios, we have to have those correct in relationship to where we're placing the angle. So let's go over to our trig ratios acronym that will be given to you and review what that means. So when you see SOHCAHTOA, you want to think of your trig function. So it's sine, cosine, or tangent. So sine of the given angle is equal to, so S means all of that. The sine of the angle is equal to, and then the O and H are your numerator and denominator. O being opposite and H being hypotenuse. So that's what you want to interpret when you see sine or so. Ka is cosine of my angle. Remember to have the angle there. Don't forget that part. Is adjacent, so the length of the adjacent side to the angle, and then divide it by the hypotenuse. And the TOA is the tangent of your angle is equal to the opposite divided by the adjacent side. Okay, those are super important. You might want to write those down as soon as you get the test as well. And then in this case, what we want to do is, again, label all of the numbers that we have. So 8.5 is my height. Again, it's related to where it is in relationship to the angle. So our 90-degree angle is sitting in this bottom left corner. So that means the 14.5 is my hypotenuse because it's across from the 90-degree angle. And the 8.5 could either be adjacent or hypotenuse, depending on where the angle is. In this case, the 8.5 is the opposite side of the angle that I've marked. So it's my opposite. Now, if I was asking for the ground, this would be adjacent. Adjacent, if I'm sitting adjacent to you, I'm sitting next to you, right? So adjacent is always next to the angle, okay? Once I have those down, then I can actually choose which trig function to use. So in this case, I know my opposite, I know my hypotenuse, I want my angle. So I have O and H. So I'm going to go over here and look for which one has O and H and use that whole equation. So the sine of the angle I'm trying to find is equal to opposite, which is the 8.5 feet, over the hypotenuse, which is 14.5 feet. Now, we started out with a tough one here because I don't know the angle, so you can't just put sine of an unknown in your calculator. I'm going to have to solve for the angle by using the inverse function of the sine. That is the sine with the -1 power. We don't call it sine to the -1, we just call it the inverse sine. And just like a square and square root, it'll get rid of that trig function. And we must do it to each side, just like when we multiply and divide. And we end up with the angle that I want is going to be equal to the inverse sine of 8.5 over 14.5. Okay, let's go to our calculator. Now, to find your inverse sine, it is almost always the same button as your sine, but you're going to shift. So inverse sine of 8.5 divided by 14.5, that's going to give me 8. It does say round to the nearest degree, so I'm going to say it's approximately 36 degrees from the ground. I do want to note, make sure in your calculator that your mode is in degrees. If I tried to change that to radians, you're going to get a whole different answer. So you want to make sure that it shows in degrees. Okay, question number 13. The angle of elevation to the top of a building in New York is found to be 8 degrees from the ground at a distance of 1 mile from the base of the building. So let's draw out this situation. I've got a building in New York, and then 8 degrees from the ground. So don't draw it from up here. And we don't go this way, right? From the ground at a distance of 1 mile. So you're a mile away. And then from the ground, I'm going up 8 degrees. So this inside bottom left angle is going to be 8 degrees. And I want to know, using this information, find the height of the building. Well, 1 mile they give you is 5,280 feet. So I'm going to use that because we don't talk about how tall buildings are in terms of miles. So we want to use that unit that I want my answer in. And again, I'm going to label these using adjacent, opposite, or hypotenuse. So we know 8 degrees is my angle. H, notice that's across, directly across from my 8 degrees. So H is my opposite. And that 5280, notice it's sitting next to, but is not the hypotenuse. So it is the adjacent side. So once I've got those labeled, I know I want opposite, I have adjacent, I need a O and A. And so in this case, we're going to want, not sine. So in this case, I'm going to want to use the tangent. Okay, let's throw it into there, into the formula. So I get tangent of 8 degrees equals the opposite side, which is my H, not to be confused with hypotenuse, but H for height, over the adjacent side, which is 5280 feet. Now I don't want to use an inverse function here because all of this is known. I'm trying to solve for H. I'm going to multiply both sides by 5280 to get rid of the fraction. Let's grab your calculator and take 5,280 multiplied by the tangent of 8. And we get the height is, and it said round to the nearest tenth. So the height is approximately 742.1. And then add the unit we're measuring in. Is it meters? Is it feet? Is it miles? Definitely not miles. So the building is 742.1 feet. Okay, moving on. Question 14. The proper angle for a ladder is about 75 degrees from the ground. So let's draw this out. And suppose you have a 24-foot ladder and you're placing it against your house. So let me place my house here. 75 degrees from the ground. Well, let's think about where I'm going to place my ladder. So I know my ladder is 24 feet. So that 75 degrees has to be on the ground, and it's not the 90 degree angle. It's going to be the other angle on the bottom because it said from the ground. Okay, and we want to know how far from the house. So not how far up the house, but how far from the house. So that's going to be my horizontal length that I'm looking for. Labeling these as opposite, adjacent, and hypotenuse. 24 is across from the 90 degree angle, so that's my hypotenuse. And 75 degrees is my, of course, angle. And I want to know X, not H or the house. I want to know X, which is adjacent to the 75 degrees. So I have adjacent and hypotenuse are the two sides that I'm dealing with in this situation. Adjacent and hypotenuse is going to be cosine. Let's plug it in. Cosine of 75 degrees is going to be equal to the adjacent side, my unknown x, over hypotenuse, which is 24. Solving for x, we're going to multiply both sides by 24. Let's take 24 multiplied by the cosine of 75, and we get x is approximately, rounding as they request to the nearest hundredths, 2 places. So that's 6.2, adding my unit, which is feet. So you want to place the ladder just over 6 feet from the house in order to have a safe angle. Okay, question 15. A tree is growing 26 feet from a home. The homeowner is worried that the tree could fall onto the house during a storm and is considering having the tree service come out and cut down the tree. To determine if the tree needs to be cut down, the homeowner stands 15 feet from the tree and measures the angle of elevation from the ground to the top of the tree to be 61 degrees. So you've got your tree here, and even though we know that the house is 26 feet away, that's not the angle that I'm dealing with. I'm standing a little bit closer to the tree, 15 feet away from the tree, or the homeowner is, and looking up, okay, for an angle of elevation from the ground. So that means that inside right angle is going to be 61 degrees. And what are we trying to find? Well, in this case, we're trying to find the height of the tree. I'm just going to call it T. So I'm trying to find the height of the tree because we want to know if it falls, is it going to hit my house that's 26 feet away? So let's take this little triangle and label everything that we know. If we label it, we know that T is across from the angle that I just described. And so T is the opposite. And the 15 is the adjacent. I don't know anything about the length, diagonally, so we aren't going to be using hypotenuse, which means that we're going to be using our tangent function. So tangent of the angle, which I know is 61, is equal to opposite, which is my T, divided by the adjacent, which is 15. We are not going to use 26 yet. We're going to compare it to 26 when we calculate this. Now, multiply both sides by 15. Let's throw that in a calculator. 15 times the tangent of 61 is going to be approximately 27.06. And again, that's the same unit that I was using for the 15 feet. So the tree is just over 27 feet. So should the homeowner have the tree cut down? Yes, or at least the top of it. And I'd say because it might hit the house because it's taller than 27 feet. Okay, let's move on to question 16. This is our last question of our trig and of the review. From the top of a 179-foot lighthouse, the angle of depression to a ship in the ocean is 13 degrees. How far is the ship from the base of the lighthouse? So they already kind of drew the triangle for us, or we might have to draw it ourselves. But let's put the numbers on there. 179 feet lighthouse, that's going to be our vertical for the tip of the lighthouse to the ocean. And then the angle of depression to a ship on the ocean is 13 degrees. This is where it's a little bit, students can make mistakes because of that word, angle of depression. So angle of depression always starts from the horizontal and then looks up or down. So imagine you're at the top of the lighthouse and normally your eyes are out, right? Out over the ocean. Now, as soon as you look down to the ocean, as you look down, that's your angle of depression. So if I was drawing this, I'm looking out, and then as I look down, that's my 13 degrees. So like inside from the horizontal down. Now, that's actually outside of your triangle. And so we're going to have to do a little more math in order to get it inside your triangle. So there's two approaches here. My preferred approach is to think about this horizontal line and my vertical line of the lighthouse as a 90-degree angle, because it's, because they're 90 degrees from each other, they're perpendicular. So this inside angle from the top of the lighthouse is going to be 90 degrees minus the 13 degrees. Okay, so we know that that is going to be 77 degrees inside the triangle. So, like this is 77 degrees here, and then 179 feet. Okay, now that's one approach. That's my preferred approach. If you understand the interior angles theorem in geometry, you know that if you have two parallel lines, so your line of sight being the top and then the ocean being the bottom, and you cut it, you know that these alternate, what they call alternate interior angles, are equal. So there's a theorem that proves that. And if you know that, you can also use that. And that would mean that if this is 13 degrees here, then this is 13 degrees, which means this inside angle is 13 degrees. Okay. I'm going to show this using both methods just in case you prefer one over the other. But I'm going to start with that use of the 77 degrees, and then I'll show you using the 13 degrees, and you can choose which one, you prefer. So if I use that 77 degrees, that's going to change whether that 179 feet vertically is considered my opposite or my adjacent. So if I'm using 77, the 179 is sitting up against it, helping form it. And so that would be the adjacent is 179 feet. Whereas if I use the 13 degrees, the 179 feet is across from it. So the opposite would be 179 feet. The other thing is we have to figure out what is the other side that I want to know. And they are asking how far is this ship from the base of the lighthouse. So they want to know this horizontal distance. So if I want to know X, I need to label that with a word. Is that, hypotenuse, opposite, adjacent? Again, that changes based on angles. So if I'm using this 77 up here, then X is opposite. Whereas if I'm using the 13 degrees, then X helps form the 13 degrees, so it's the adjacent. So those two just flip-flop whether I'm using the 77 degrees or the 13 degrees. Beautiful thing about math is they will both work out to be the exact same answer, and I'll show you that. Okay, so I have or want to know opposite and adjacent with my 77 degrees. And so that's going to be my tangent. So I'm going to use tangent of 77 is equal to, remember, TOA, opposite, that's my X, that's my unknown, over adjacent, which is 179. This looks very familiar. We've solved problems like this before. You would just multiply both sides by 179. So let's go ahead and do that. Let's take 179 and multiply it by the tangent of 77. And we get our answer. X, or that horizontal distance, is going to be 775. They asked us to round it to the nearest foot. So we can just say approximately 775 feet, okay, from the ship to the base of the lighthouse. Okay, let's set up the second way. If you used 13 degrees as your angle, you still have adjacent and opposite. So I'm still using tangent, but I'm going to use the 13 degrees, and that's equal to, remember, opposite first, In this case, the opposite was the 179, and your adjacent is x. So those have kind of flip-flopped, right? They've inverted. So how do I solve this? Well, this is a little more complicated algebra, but it's still solvable. My preferred way to solve this is the same way I did this other problem, but it adds an extra step. I still don't like the denominator, but it happens to be a variable. So I'm going to just multiply both sides by x, just like I multiplied by the 179. But this time the x's cancel on the right, leaving me x times tangent of 13 on the left and 179 on the right. Okay, so now I still need to solve for x because x isn't isolated. Since it's being multiplied by that tangent, I'm going to divide by the tangent of 13. So slightly more complicated algebra to solve for it, but here's the fun part. So let's go ahead and put that in your calculator, see what you get. Take 179 divided by the tangent of 13. But you get the exact same answer. So that's the beauty in math. You can do it in multiple ways. I don't care which way you take, just show me all of your work. And I hope that helps. That's the end of our review. If you have more questions, please feel free to add them in the discussion board, and I wish you the best of luck on your test. Thanks, guys.